And welcome back. It is the 5th of August, high five a day, and let's go straight to the first question. So the first question, actually I thought it was a quadratic, but it's not a quadratic, is it? So this first question is basically just a solve. So I'm going to add 75 to both sides, which is going to give me this. I'm going to divide both sides by 3, which is going to give me 25. And I'm going to square root both sides, which means x is equal to 5. Of course, part of the point of the question is when I take the square root to solve, it could be the plus answer or the minus answer. So therefore my answers are 5 or minus 5. Point of the question is knowing about the square root solutions. Next question. A solid metal cylinder is melted down and the metal is made into solid spheres. Again, I guess here it wants how many whole spheres, doesn't it? So how many whole spheres are made? Now the way I'm going to do that is I'm going to work out the volume of the cylinder. So the volume of the cylinder is going to be what's pi r squared times h. It's going to be pi times the radius, which I can see from the diagram is 14, times by the height, which is 8. Then I'm going to divide that by the volume of a sphere, and each sphere is 4/3 times pi times by the radius cubed, which it tells me the question is that. I can pretty much do that in my calculator in one go. So firstly, I would note the pi's cancel. Then I would get my calculator out in the fraction button mode. Very carefully, I would type all that in. And that gives me 147 over 8 on the calculator, or 18.375. So I'll just write that down. So 18.375 working step. But again, the question says, well, it doesn't actually say it, but I presume it means how many complete spheres, which implies the answer to my question is 18. Again, working shown, just to make sure I get those marks. Next question. Tyrone invests £500 in a savings account that pays 2% compound. How many years will it take for Tyrone to earn at least £600 in interest? Okay, interesting question, or interesting way of putting it. So I want to do 500 times 1.02 as my multiplier for m years, and I want to get not 600 because that's my interest on top of the 500, so I want to get that. Now, unless you do logs and A level, the only way you're going to do this is basically just try different numbers. I can tell you, because it's more than doubling, this number is going to be quite large. So basically, and what I'm going to do, so you know, is I'm going to play with some numbers off screen, pause the video, come back and let you know what I've come up with. Okay, so I've played with some numbers, and what I've seen is if I do 500 times 1.02 to the 39, and 500 times 1.02 to the 40, that gives me respectively 1082. Again, I don't need the numbers afterwards, and 1104. And of course, the point is this breaches the level I care about. So the answer to the question is 40 years, because I need the whole of that 40th year to get above 1100. Question done. Next question. In a netball league, there are 8 teams. Each team plays each other team. Right, okay, so there's 1, 2, 3, 4, 5, 6, 7, 8 different teams. If each team plays each other team, presumably, well, actually, it does say the word once, so once and once only. The thing to notice here is this team here can play any one of 7 other teams. This team here can also play any one of the other 7, but I've already made that link there. So therefore that is 6, and the next one is 5, the next one is 4, then it's 3, then it's 2, then it's 1. I'm going to add all these numbers up, and that's going to give me 28 overall. Good question. Next one, and final one today. In 1892, a woman's age was the square root of the number of the year of her birth. Now, this is quite a difficult question. In fact, it's a very difficult question to end today on. 2 ways of doing it, and I don't know which one's going to be easier at the top of my head. So I'm going to say, because the thing I want is the year she was born. So I'm going to say that's X. So it must be the case that her age is going to be 1892 minus X. And it says in 1892, a woman's age was the square root of the number of the year of her birth. So in other words, that is equal to the square root of X. Now that's quite messy. So I'm going to square both sides. This is not going to be nice. I'm fully presuming it's a calculator question. So therefore 1892 minus X squared is equal to X. Again, didn't say this was going to be nice, not nice at all. Expand the brackets, which means that X squared minus, now 1892, if I expand this, I'm doing this on my calculator, that's going to give me minus 3784X plus 8, I'm not going to work it out because it's going to be horrible. I'm just going to write 1892 squared is equal to X, which does at least give me a quadratic of X squared minus 3784X. Take away another X is going to give me 3785X. plus 118.92 squared is equal to 0. Now, before I do the next step, the good news here is I must get a nice whole number. I'm presuming it wants me to use algebra. It will say it in the exam, because to be honest, it might just be easy just to try different numbers and see which one works. But either way, I'm going to use a quadratic formula because I can't factorize this. Sure, it works out, but I can't do that in my head. So therefore, x is going to be equal to, now bear in mind, this is going to be awful, but if I don't get a nice integer answer, I've done the wrong thing. So it's going to be 3785 squared minus 4 times 1 times 1892 squared. Wow. And dividing all that by, 28? So divide all that by 2. Let's do the square root first. So that tells me 3785 squared minus 4 times 1892 squared, in my calculator carefully. Good news is 87. I'm very happy about that because, let me just write it out, because that means I've got an integer answer. If I do my plus number and my minus number, what does that give me? So my plus number gives me 1936 and my minus number gives me 1849. Now, I'm going to pause the video there for a second, or actually I'm going to pause for a second, so I'm going to ask you a question. One of those is very clearly correct and one of those is wrong. Which one and why? And hopefully what you realise is it can't be that one. She can't be born after the year I'm talking about. So it must be this one. So that felt like a horribly difficult question, but my final answer is 1849. Good question, and a really difficult question to end today. So I quite enjoyed that one. Definitely, I suspect a longer video today, but either way, let me know how it went for you. Do like, subscribe. See you tomorrow.